Hey YouTube, this is my first in a series of videos in which we're going to confront how we solve a quadratic equations, which is one of my favorite things to do because we've got several different methods we can use in order to do so. So let's start by defining what we mean by a quadratic equation. Recall that a polynomial is just the sum of several many different degree terms, and when we refer to a quadratic equation in X, we say it's an equation that can be written in general form, which just means that we have this standard form polynomial here where our exponents are going in decreasing order and we set it equal to 0. We would refer to this as a quadratic equation, and quadratic because this is a second degree polynomial. So we have this ax squared plus bx plus c, and when we set that equal to 0, we refer to that as the general form of this. Anytime you set it equal to 0, it's the general form. So we say a, b, and c are all real numbers, and we don't allow a to be 0 just because of the fact that if it is 0, then we're left with this linear thing, this first degree polynomial. And that's not what we're talking about in this video. We're talking about quadratic equations. So we say a quadratic equation in X is also called a second degree polynomial equation in X, which just makes reasonable sense since quadratic things are of second degree. So off to the right here, you'll see that we have this quadratic equation, and the most important thing is this. It is set equal to 0. So we set equal to 0. Whenever you deal with a quadratic equation, this is like step number 1. We're always going to do this first. But once we get this down to this form here, we say this standard form on the left, we can identify these values of a, b, and c. And that's going to be integral as we solve these. So we say a in this case is our leading coefficient 1, and we have -7 as our b, and we have a c term of c. It has a value of 10. A c term of 10 has a value of 10. So what we want to do is solve this equation. Now, one thing I'll point out here is this. I'm just going to get this out of the way right now. If you try to solve this by isolating x, we're going to run into the problem of having the fact that we have one is an x to the first, one term, and the other one has an x to the second. So even if I were to displace this term and this term over to the other side, I get x squared equal to, like, positive 7x minus 10. Taking the square root of both sides is just really, it's a valid statement, but it is just not a helpful thing because this is kind of like defining x in terms of itself, which we don't really want to find x in terms of itself. We want to find some numerical values if at all possible. So in this first video, we are going to talk about my favorite method of solving polynomial equations, which is solving by factoring. And in order to do this, we're going to have to borrow from what we call the zero product principle. So let's read through the zero product principle, and I'll talk to you how I can use that to solve these quadratic equations you see here. So it says if the product of two algebraic expressions is 0, I would like to say if the product of two algebraic expressions or two or more algebraic expressions is 0, then at least one of the factors is equal to 0. So that is to say, if two things are multiplied together in this particular instance, and they equal 0, then either A is 0 or B is 0 or they both are 0. So what is beneficial about that, being able to make that statement, is that if we can take this is really a sum and difference here kind of several terms and rewrite this as something times something equals 0, then what we could say is one of those things has to be 0. So I notice that this is a trinomial. It certainly does factor into a couple of binomials times each other. So I would say x times x gives me this. Now can I think of two numbers in the last part of my unfoiling here, this L part. We got the F part done. That multiply out to be a positive 10, and it, as a matter of fact, at the same time add up to be a -7. In this particular instance, I could think of -5 and -2 would accomplish this task. So I want you to notice here, using the zero product principle, we say that this is like our A, and this is like our B. And if this times this equals 0, then either this can be concluded, x minus 5 is equal to 0, or x minus 2 is equal to 0. So the method of solving by factoring is essentially this. Factor the statement into a product of factors, and if that product equals 0, then we can just go take all of the individual factors and set them equal to 0. And the reason why that's beneficial is because, well, if I solve this one right here individually, I get the solution x is 5. And over here I would solve this by adding 2 to both sides, and I would get x equals 2. And this polynomial is solved. And I do want to check this. As a matter of fact, if we plug these back in, we had x squared minus 7 times x plus 10 equals 0. I want you to see that if I were to plug in a 5 right here and a 5 right here, we would get this. We would get 25 is 5 squared minus 35 right here plus 10 equals 0. And this is indeed true because -10 is what we get in that first difference right here. And we say -10 plus positive 10, this is 0. And likewise, if we were to go back now and put in not positive 5, but this positive 2, we would get 2 squared, which is 4, minus 2 times 7, which is 14, plus 10 equals 0. In other words, we get -4. Sorry, I'm thinking -4 here. -10 plus 10. is 0. And you can see that it also checks out here. We get 0 is 0. So the fact is, we can just factor this and then set all of the individual factors equals to 0 if and only if we set it equal to 0 in the first place and these things multiply together equals 0. So just very quickly here, let's read through this. It says, if we want to solve a quadratic equation, we say if necessary, go ahead and write it in general form. In other words, move all non-zero terms to one side, thereby obtaining a 0 on the other side. That's this step up here that says set it equal to 0. And then we're just going to factor it and then apply the zero product principle, which means set each of those individual factors containing a variable equal to 0, and then just solve those individual equations, which are usually in this case first degree equations here. So what we're going to look at are these two examples. I would actually recommend you pause the video and try them on your own, but I notice if you want to see the solutions, you can go ahead and keep playing here. That this one's already set equal to 0, this quadratic thing. So the first thing I want to do is factor it. And I notice that the common factor here is 3x between both of these terms. Remember, when you factor, always look for a GCF first. So I'm left with x squared, 3x squared becoming an x, and then we say negative 9 divided by a positive 3 is this 3 here, and we took that x out. So here's my factored expression, where in this instance, this is like our a and this is like our b. So either 3x is equal to 0 or x minus 3 is equal to 0. Somebody here is 0. So this one right here, we can add 3 to both sides and we get the conclusion that, well, x must be 3. Or we can divide this both sides by 3. And we can say, well, then x equals 0 divided by 3, which is this right here. So these are our two solutions. One thing I do want to mention, though, is this. As we move forward, we will be writing the set of solutions as a set in set notation. So here is our set of solutions. We say solutions. And we'd say it's the set containing 0 and 3. So now looking at the statement on the right, the first thing I notice is this. It's certainly quadratic, it's a second degree polynomial, but it's not equal to 0. So the first thing I want to do is bring this one back over. So I get 2x squared plus x minus 1 equal to 0, and I'm going to try to factor this. So because it's a trinomial, I'm going to try to get the product of two binomials, and using that unfoil method, we're going to start with the f part here. I would say that what can I multiply in the front of these two parentheses to get 2x squared? Well, I'd take a 2x times an x. And furthermore, I'd say, well, what can I multiply now in the back part, the last part, to get this negative 1? Well, one's got to be a positive 1, the other one's got to be a negative 1. So maybe I'd try like negative 1, positive 1. And we have to check this. I mean, that works out right now for the f and the l parts, but this middle, we needed to get a 1x in the middle. So you check your outside and your inside in this foil. And we notice we get 2x times x is 2x. And then negative 1 times x is negative x, and we get 2x minus x is x, which is exactly what we wanted to get in the middle. So these are indeed our factors here, and now we'll just go ahead and set these individually equal to 0 and solve them. So either 2x minus 1 equaled 0, or x plus 1 equaled 0. One of them did. So this one here we get the conclusion negative 1. And then here we'd have to add the 1 first. We say 2x equals 1, but then it follows that x would have to be 1 divided by 2, or x equals a half. We could certainly plug this back in and check it, but for now, I just want you to know that this is our method for solving for solutions by factoring. Just factor it, set it equal to 0, factor it, and set the individual factors equal to 0 and solve those. Cheers.